And we'll come back. Okay, so we've got today we'll talk about object-oriented programming in R. We've gone through a lot of R. You can get through a lot of R programming without worrying about object-oriented stuff. But it is, I would say, it is useful to know at least that this object-oriented stuff does exist, and that you can define objects or classes of objects to kind of make your life easier should the need arise. Okay. It also explains how some of the other functions that are commonly used work in R. Okay. So we'll take a look. I'm pretty much using Hadley Wickham's notes on the topic here, but let's see. And I've posted these online already, so you can kind of download them and follow along. And if I need to make changes or something, I'll do that and update them. Okay, so we're gonna look at it's a field guide for recognizing and working with R's objects in the wild quote. There's 3 object-oriented systems plus the base types, and we're not really going to become an expert in any of this, but at least we'll become familiar with this. All right, so we have classes and we have methods. All right, classes are the type of object. They define objects and their behaviors. Okay, and then we have methods, which are functions that work differently based on the object that is being fed into the method. Okay, so so the method will look at the class of the object and operate differently. Okay, and so oftentimes we'll have classes in some kind of hierarchy. So we'll have a certain type of class which inherits a lot of the properties from its quote parent class. Okay, and so when you feed the function a certain class, if it doesn't find a method specifically for that class, it will apply the method that applies to the kind of the parent of that class, and so on. Okay, so the 3 systems are S3, which is the kind of the generic, well, not generic. It's the object-oriented system that's most commonly used in R, and I'd say this is probably the one that we should familiarize ourselves with the most. Okay, so this is the S3 system, and then there's S4, which makes the object-oriented system a bit more formal. Okay, maybe a little bit more similar to other languages, and then there's reference classes. Okay, and reference classes are unique in that functions can actually modify the reference class object. Okay, so normally functions don't modify objects in place. Normally you give a function a set of arguments, and then when you run the function returns a result, and then you have to save that result somewhere else. Okay, if you have a reference class, you can create a function that will, whenever you run the function, it alters a separate object. Okay, which is the reference class object. Okay, we'll talk about each of these things in a bit more detail here. Okay. Oh, and then there's the base types. Okay, and so as far as R, the language itself is written, a lot of it is written in Fortran and C, okay? And so a lot of these, quote, base types, the base types are kind of C level objects, and only the R core team can create base types. So, you and I will not be allowed to create base types, and they're very rarely added. Okay, so let's oh, it says prerequisites, you'll need to install the prior package. Okay, and so as you know, the reason for installing the prior package is that the regular R language doesn't include just certain functions to look up what type of object something is. Okay, and so Hadley Wickham wrote this package called prior, which is used to pry the R objects open to see kind of their internal workings. Okay, so let's talk about base types. It says underlying every R object is a C structure that describes how the object is stored in memory. Okay, the structure includes the contents of the object, the information needed for memory management, and most importantly for this section, a type. This is the base type of an R object. Base types are not really an object system because only the R team can create new types. Here, let me zoom in. Okay, as a result, new base types are added very rarely. Okay, and then so some of the base types we've already covered are atomic vectors and lists. Those are base types. Okay, and base types also include functions, environments, and then other objects like calls and promises. Okay, and I don't know if you've ever encountered sometimes if you ask R to load a data set and you look in RStudio, sometimes it'll show up as promise, which sounds a little bit funny, but it is a base type. Okay, and so usually you just look up something with type of. Okay, you use the function type of, and it'll return back, and it'll say something like list or numeric vector type thing. Okay, and as Hadley notes, it says, unfortunately, the names of base types are not used consistently throughout R, and type and the corresponding is function may use different names. So, for example, we have the function, if we just define some kind of function which really does nothing, okay, as f, and then we ask what is the type of for f, it's going to return closure, but is it a function? Yes, it's a function. Okay, so a lot of times we would expect these things to be the same, but it's not. Okay, and then we have other functions. So for example, there's the function sum, which adds up all the numbers together. And if we ask the type of for the function sum, it's going to say it's a built-in. Okay, but that's but really what it is it's called a primitive function, which basically means that it's written up in C. Okay, so if you want to know how does R compute a sum, okay, you're not going to get R code. So a lot of times, if you go in R and you want to know like how does a certain function work, sometimes you can just write out the name of the function and see so if you type in the word sum without the parentheses, okay, it will say it's a function, but how does it work? Call the C primitive called sum. Okay, whereas other things like let's make a linear model. Okay, here you get R code. Okay, if you ask how does the linear model work, it returns R code, and you can actually go through and we can understand how all of the we can read through all of the R code here and try to understand exactly what's going on here. Okay, and of course it's making calls to other functions inside the code here. But a lot of times you can just, if there's a, there's some kind of function, it will, if we ask for a plot, okay, we see it does call a function, but it uses something called use method, okay, and so we'll look up what all of this means. All right. So, whoops. Okay, so yeah, you can ask type of for f and sum. Oh yeah, so let's do that. So we'll do type of for sum, and it says it's a built-in. If I just say type of for the function lm, it will say closure. Okay. So, and if I say is function sum, it'll say true, and then is function lm, that will also say true. But then if we can ask is.primitive sum, that's true, but the function linear model is not. Okay. All right, so anyway, what is all this? Okay, so those are kind of the base types. There's another thing called mode, but just use type of, okay. And then, so functions that behave differently for different base types are almost always written in C, where dispatch occurs using switch statements. Okay, so this is, yeah, I guess we don't really have to worry about this. It says, even if you never write C code, it's important to understand base types because everything is built on top of them. S3 objects can be built on any type of base type, and S4 uses a special base type, and reference class objects are a combination of S4 and environments. Okay. You can do is.object, and is.object will return false if it's a base type. Okay. All right. So let's talk about S3. Okay. It says S3 is R's first and simplest object-oriented system. Okay, it's the only object-oriented system or OO system used in the base and stat packages, and it's the most commonly used system in CRAN packages. Okay, so pretty much any of the objects, if you don't load any libraries or any other packages, any objects that are created in R at that point are all implemented in S3. Okay, so you can do quite a bit with S3. The other object-oriented systems just add some formality or some nice features that sometimes are necessary for programming. Okay, it says S3 is informal and ad hoc, but it has a certain elegance in its minimalism. You can't take away any part of it and still have a useful object-oriented system. Okay, and that's true. And it says most objects that you encounter are S3 objects. And then unfortunately there is no simple test to see if S3 is if it's an S3 object in base R. So that's why we've loaded that library prior, because prior has implemented a function called OType, object type, to tell you if it's an S3 type of object. Okay, but I guess you can tell if something is an S3 object because you have to say, is it an object? And it should return true, but then it needs to say it's not S4. Okay, but yeah, we don't have a is it an S3? Okay, so here is library prior. So for example, the data frame. The data frame is an S3 object, okay? But then if you extract out the X column in a data frame where it's just now a numeric vector, that is that's a base object type, okay? Whereas a factor, the letters in Y, is an S3 object. Okay? So why does all of this matter? All right. Okay. It says in S3, methods belong to functions called generic functions, okay, or we might call them generics. Okay, S3 methods do not belong to objects or classes. Okay, so in a lot of other object-oriented systems, you have methods that belong to a certain class. So you define the object, and then you have the function that applies to that class, and it only works that way. In S3, you just have a generic function, okay, and then and those are the methods, okay, and then it says to determine if a function is an S3 generic, you can expect a source code for a call to use method, okay, and that's how it dispatches the methods, okay. And so it says, yeah, use method is the function that figures out the correct method to call. The process of method dispatch, similar to O-type, prior also provides F-type, which describes the object system if associated with a function. Okay, so for example, I've already showed you that if we looked at the function plot, okay, and get rid of the parentheses, we see a call to the function use method. Okay, use method plot, and then same with mean. Okay, if you get rid of the parentheses to ask, how is it defined, it says it's going to do use method mean. Is this legible? Maybe I'll make my okay. All right, so we can see the calls to use method there. And this actually, let me load library prior. Okay, and then so F-type, which is a function that only exists in prior, we'll say, okay, it uses the S3 object-oriented system, or it's a generic function. Okay. All right. So what exactly is this? Okay. Okay. Oh, and all right. Yeah, actually. So it says some S3 generics, like kind of the bracket, sum, and cbind, don't call use method because they're implemented in C. Instead, they call the C functions dispatch group or dispatch or evaluate. Okay, functions that do method dispatch in C are called internal generics and are documented in internal generic. Okay, so for example, we can look at what is sum. Okay, and it'll say it's a primitive, and if I ask for F-type of sum, okay, it'll say it's a primitive or a generic there. Okay. And then you can ask what is internal generic, all right? And it kind of lists off some of these. These are like internal generics that exist, okay? Okay, so, but, all right, so other than these kind of special cases, for the other S3 objects, okay, so like the mean and plot or whatever, it says the job as an S3 generic is to call the right S3 method. You can recognize S3 methods by their names, which look like the generic name dot the class. Okay, so for example, the date method for mean, the mean generic is called mean.date, and the print method, the factor method for print is called print.factor. Okay, so if we so when we ask for how does mean work, again, it calls use method for mean, but we can look up mean.date. Okay, and so this is a specific function called mean. This is the mean function as it applies for date objects of class date, okay? And then and it says, you know, if you look at the code here, it says mean, and then it says basically remove the class, unclass the date object, okay? Calculate the mean of that unclassed object, and then turn it back into a date, okay? So the way it's calculating, if we give it a bunch of date data, okay, so let me, how can I, blah, 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 blah. Well, I don't feel like doing this. Like, let me do, I guess I can do library lubridate. Okay, and then we can do, no, this messes it up. Because it's now, this introduces its own things. Okay, but anyway, you can see that. So when you call, like if we give it a date object, okay, so I don't know how to unload my packages. How do I? Lubridates. Ah, that's right. Okay. Huh? But I think that removes the package. I want to just get rid of it from memory, but that's okay. So anyway, let me see. Okay, and then yeah, print.factor. Okay. Oh yeah, that actually will make sense. Okay, so if I call up the print command, okay, and remove the things, we see, you know, it calls use method print, okay, and then we can create a factor, right? So we can do, so I'm going to create an object A, which is going to be a factor of basically letters 1 through 5, okay? So if we ask, you know, A, it's going to print out A, B, C, D, E, and it will say the levels are A, B, C, D, E, right? And then if we do a type of A, it will say it's actually an integer, okay? So I can actually do as.integer A, and we can see that it's actually stored this way, okay? We can say O type of A using our kind of our prior thing, and it'll say it's an S3 thing. And if we ask, you know, what's the class of A, it's a factor, okay? So anyway, if I call the print function, okay, print on A, it prints it out, okay, which is basically the default command. If you just type in the letter, the way it prints out will look like this, which is different from if I print just like character information or integer information, okay? So to see why is it printing out this way, we can look up the function print.factor, okay? Print.factor, okay, now returns all of this, but basically it's going to say, you know, it's just saying, you know, what is all of this stuff, okay? You know, is it ordered, okay? If it's not, then figure out kind of the levels, and so these are all of the code. This is all the code just to get it to print, okay? And I think it's all right here where so at this point it figures out what TO is, and it says the levels are this, and it kind of prints out all of the levels, and then it kind of concatenates all of it together. So when you call on print onto A, what it's really doing is it's doing print.factor of A, okay? And that's handled by using the use method, okay? So method dispatch, what it does is you call print on A, it's going to go to use method, and use method looks up kind of the class of A, and it says, oh, it's a factor. I actually have to use the function print.factor, okay? And if I look up other things like print.date, if I do print.date a, it gets confused and it tries to it has to do something else, okay? And this is not the way print.date is supposed to. Print.date is designed for date data, okay? Okay, so anyway, when you name objects and stuff, we discourage the use of using a dot because the dots are intended for kind of these method dispatch things, okay, for use dot method. So for example, if you were to name something data.frame, okay, and so things have already been implemented, so they're kind of, this is the way it is, but you can see where confusion could arise, okay? So if you create something, there is already an object called data.frames, okay? But if you if you were to create something called data.frame and we called print.data.frame, okay, there's some ambiguity, okay? Okay, what print.data.frame is it's the print method for data.frames, okay? But it could be, is it the print.data method for the frames type, okay? And then we have a kind of a function called t.test, basically a t-test, and but the way this is printed looks like, is it the t method, which is generally transpose for like matrix objects and stuff like that? Is it the t method for test objects? It's not, okay? And so we've implemented this, and I mean these are known things that exist in the system, but whenever you create objects, we discourage the use of the dot instead of the space. So you should use kind of like an underscore and things like that, okay? Okay, and yeah, F-type knows about these exceptions here. Okay. So yeah, we can look at the methods that belong to a generic function, such as mean or print or whatever. So we can look up the methods associated with. Do I use quotes there? Yeah. With mean. Okay. We have mean.date, mean default, mean.difference time, mean.posix, and mean. Okay. So we have different, if we asked for mean.default, this is the regular, if it doesn't find, like if you give the mean function a date object, it will create the, it will call that specific method, okay? This is the default mean command, okay? So again, when we ask for mean and we look at it up, it uses method, and then what it really is doing is that it's just calling, it's saying figure out which one of these to use. If it's not, if you don't have something like diff time, posix ct, or posix lt, which are just kind of these slightly more exotic objects, it's going to call the default mean function, okay? And the default mean function pretty much does all of this stuff that says like we can't do all of these weird things, and then finally it calls to dot internal mean, which is the kind of the C code, C level code for the mean function. Whoops. Or we could ask what are the methods for print, and there's going to be a lot, okay? Because there's all these different types of objects. Okay, we've got, ANOVA, print.aov, print. All of these different different things. So the way it prints out a linear model object, or the way it prints out, I don't know, all of these other things, prints a table or warnings or whatever. Okay, all of these things get their own method for printing stuff out. I think, we could ask methods for plot, and there will be a bunch also. Okay, so when you ask for it to plot different things, it's gonna plot them different ways, right? So you could say, so for example, so, maybe I'll create a object called model, which is going to be a linear model of y as explained by x. Okay, I'm hoping you guys have seen the creation of linear models and stuff like this. So this is like the most basic thing, right? I've just plotted 1, 2, 3, 4 versus 2, 6, 4, 8. Okay, and we're going to call it to do the model, right? And then so if I do if I type out model, which is basically just I'm calling it to print the model, this is what it's doing, okay? And so, but what it's really calling is it's doing print.lm of our object model. Oops. Could not find print. Is that not right? Oh, I'm sorry. I thought it was print.lm. Is it print.lm star? Nah. Making me look bad here. Okay. All right. Well, there's a specific object type, and then again, when I'm calling plot the model, it gives you a series of kind of plots, right? It gives you this thing, and it gives you this thing, and it gives you this thing. It gives you all of these different plots, right? And then so again, what it's doing is it's dispatching the plot specific to the linear model, except no, I'm not sure, because these have little asterisks, so it must be calling something else here. But at some point, it's basically asking what is the object type of model, which is it's basically it's a linear mod. The class of model is LM, okay, and it's pulling the appropriate method there, the function there, okay. Okay, so we have methods associated with certain types, so we can say, what are the methods associated with class equal to linear model, okay, and we have the print method and the plot method, and they have their own. This means we have our own special things. So if you look up methods and you have a linear model object, you can say, okay, well, now give me ANOVA for the model, or give me, maybe you're not quite sure what all of these different things are. You can just say, confidence interval for the model. All right, and then so these are all. We've created a model of class LM, and these are all the different methods associated with the object here. Okay, so but if we look at model itself, so if we ask what is the class of model, it's a linear model class, LM class. But if we ask how is it stored internally, okay, it's just stored as a list, okay, and we can ask if I tell it to unclass the model, okay, it kind of just strips all of the special features of the model, and then we see, if we unclass the model, it's just a list where you've got coefficients, residuals, effects, rank, fitted values, assign, QR, and it's got all of these inside the model that's got all of these different things, and then a bunch of attributes. Okay, so the linear, the object model is really just a list with all of these different things, but it's under the object class of LM, and because of that, you know, when you normally just ask to what is model, you know, it kind of prints it out like this, and you know, summary model will print out certain print things out kind of the way we like to see the information presented. Okay, but internally it's just stored as a list with all of kind of these extra instructions that say, you know, when we call it, ask R to print things out, do it like that. Okay, and again, you know, when you call it on the summary function, okay, you know, it's just using use method.summary. So maybe there's a summary. Yeah, so summary for LM is basically the special instructions. So it's a lot. Okay, but this is the function that's basically being called on the LM object. Okay, and so anyway, that's what we have. Okay. All right, so you know, with S3, if you wanted to create objects and stuff in S3, it says S3 is a simple and ad hoc system. It has no formal definition of a class. To make an object an instance of a class, you just take an existing base object and set the class attribute. Okay, and so you can do that during creation with structure or after the fact with class. Okay, so here we're just making up a new class called foo. All right, which is just a kind of a placeholder thing, and we're going to just say, okay, foo is this object foo is going to be basically an empty list, but now we've given it the class foo. Okay, or we could do it this way. We can say make foo to be a list. Okay, oh, and now we're going to say the class of foo is foo. Okay, and then and here it says S3 objects are usually built on top of lists or atomic vectors with attributes, and you can also turn functions into S3 objects, and other base types are rarely seen that don't usually work as well, but you know, you can see, and it says you can determine the class using the class command or function, and you can see if an object inherits from a specific class using inherits. Okay, so this is where we go. So does foo inherit the properties of foo? Yes, it does. Okay. All right. The class of an S3 object can be a vector which describes behavior from most to least specific. Okay. So for example, if we ask the class on GLM, okay, of a GLM object, whoops. Yeah. Oh no, that's. Okay, so let me create model 2, which will be GLM, we'll say y explained by x. Okay, and we ask for the class of model 2, which is a GLM object. Okay, its class type is GLM, but then if it doesn't find methods specific to GLM, then it will find kind of methods specific to LM. And if it doesn't find methods specific to GLM or LM, it will go to the generic method. Okay. Okay, and then just other stuff for naming things. Okay. Most of the S3 classes provide a constructor function. Okay, so for example, so here is you know, if we wanted to create a class called foo, we should have a function that basically makes things of class foo. Okay, and so foo ends up just being a function where you've got structure is this. Okay, so you should use it. So for example, if we looked at what is the internal, so internal code for factor. Okay, this is the constructor function. This is basically, you know, if I say do factor of kind of A and B, it creates a factor of A and B with levels A and B, okay? And so basically what it's saying is that, this is how it's creating the factor. It's going to, look for missing levels. It's going to do as.character and all of this stuff. And basically at the end, it's saying, assign the class to be factor. So after you've created all of factor stuff, assign the class to be factor, and then the last thing is return that object f. Okay, so you can learn a lot about R just by looking at kind of the functions, the internal functions. You just basically call the function, whether it's factor or plot or whatever. A lot of times, when you're learning R, all of this code is just, maybe it's a little bit too much all at once, but it's there. Okay. And so you can, so here's a, we've created a linear model, and then, we can ask the class on the linear model, and it'll say LM, and then when we print it, it prints it out with the method specific to that class, okay? And you can do stuff to the object, okay? And you can change the class, all right? So you could turn the linear model, okay, object mod, and if we ask for the class, it's the class is LM, but you could turn it into data.frame, okay? And you don't want to do this. This is a bad idea in general, but you could, and R will say, okay, I'm going to try this out, and then if you print it out now, if you say print this thing, it's going to try to print it out using the method specific to data frames, okay? Which now basically just gives it the column headings and says, like, look what you've done. But it didn't delete any of the data. It's still there. It's just it doesn't know how to print it. So if we ask, what's the mod.coefficients, that information is still there. Okay, it's just now you've changed the way the method dispatch works, right? So normally the model is of type LM, so when you say print model or print mod, it's going to look up the print method specific to class LM. Now that we've reassigned it to data frame, it's looking up the print method specific to data frame, and it doesn't quite know what to do, okay? So it says, basically it says R doesn't protect you from yourself. You can easily shoot yourself in the foot, okay? But as long as you don't aim the gun at your foot and pull the trigger, you won't have a problem. So basically, don't do stupid stuff. But, and it could be that in your code you've done something dumb without realizing it. But that's what we have, okay? We could create, oh, okay, it's 9:54. Why don't we take a 5-minute stretch break, and then we'll continue on all